This tutorial shows you how to use the command line version of the population genetics software structure. See the show notes below for another video I made about this program, what it does, and what it is used for. In fact, there are several other useful videos about structure on my website, joshbanta.com. See the show notes below. This tutorial assumes you are using Ubuntu Linux version 20.04 as your operating system. If you do not have Linux, you can emulate it on your Windows or Mac computer for free. See the show notes for details. In fact, I am emulating Linux right now on my Mac computer using VirtualBox. Speaking of which, I have a VirtualBox virtual machine pre-configured with the software I will show you today, as well as other population genetics and ecological niche modeling software. See the show notes below for step-by-step instructions to download and hook up this virtual machine within your Windows or Mac computer. This tutorial also assumes you have the program Structure installed. See the show notes below for a tutorial on how to install Structure on your Linux machine. Or you can use the pre-configured virtual machine I mentioned earlier, the one that you see me using right now. First, open up a web browser and navigate to my website, joshbanta.com. Then click on Tutorials. Next, scroll down quite far until you find How to Install Structure on Ubuntu Linux version 20.04. This tutorial is not about installing Structure, but the files for this tutorial are the same ones that I will use to show you how to run Structure. So click on Files Needed for Tutorial. Once the page is finished loading, click the Download button and select Direct Download. After the download is complete, you can close your browser window. Open up File Explorer, which you may have pinned to the side as on my virtual machine, or you can search for it below. Navigate to your Downloads folder and double-click on the file we just downloaded, structurelinux.zip. Double-click on the folder Structure Linux. In there, there's a folder called Console. This is the folder that we want. But this folder is inside of a zip archive, meaning that the files within this folder cannot be accessed by the other programs. We need to move this folder out of the compressed archive in order to unzip it and to make the folder available. Open up File Explorer, or if you still have it open, click on it. Navigate to your home folder, and I keep all the program files mostly in a folder I've made called bin, which I keep within my home folder. But if you're not using my virtual machine, you could use any location that you choose. If you are using my virtual machine, you're going to want to put it into the bin folder. Come back to your archive manager, click on the console folder, drag it over to the bin folder. Now it says replace file test data. Here's what's happening. I already have the folder console within the bin directory of the home folder on my virtual machine. If you're not using my virtual machine, you won't be getting this message. But because I already have the console folder in the bin directory on my virtual machine, it's asking you about replacing the files that are already there. We're going to click on Replace All because I want to take a fresh version of the folder that we just downloaded from my website and put it into the bin directory so that we can start fresh. Now that it's finished, close the Archive Manager. Now let's open up the console folder that we uncompressed into this location. So we started by double-clicking on the bin folder within the home directory, and then double-click on the console folder. I'd like to tell you about this file output.prn. This file may be called something else, depending upon how you converted your data into the structure format. But this is the file that we will be using. This is the file containing the data in structure format for our purposes in this tutorial. Again, if you're using your own data that you've converted into the structure format, this file may be called something else. I'll assume your file is called output.prn in the remainder of this tutorial, but you'll need to adjust my directions to fit the name of your file that you converted for structure if it's called something else. Also, you'll really need this file structureinfo.csv. This file contains information about the number of individuals and the number of loci in your study. If you do not have this file, for instance, if you converted your own data into the structure format using some program that you found, you won't have this file, in which case you'll need to figure out the number of individuals and the number of loci in your study on your own. And you better be accurate because structure is very picky about that. I recommend to use my tutorial to convert your files into the structure format. I have a link to this previous tutorial in the show notes below. Or if you'd like to just use the sample tutorial data I provide here, not your own data, you can just follow along with the files that I have provided right here. But if you're using your own data, make sure you copy your file that's in the structure format into this console folder. Or else, if you're using my sample data, just follow along using the sample data I am using for this tutorial.
So if we double click on it, it'll attempt to open it in LibreOffice, but all we need is the information that's right here. The number of loci is 5,546 and the number of individuals is 8. The no data character in my data set is -999. I have my data set set up so that it includes a row of marker names for the loci, as well as a column of individual names. So let's start by editing this file called main params. Don't worry about this setting here for defining the number of K clusters. This setting will be overwritten later on when we add some extra commands in the terminal window. It's important, though, to set these two parameters appropriately, the burn-in and then the number of runs after the burn-in. Typically, you want your burn-in period to be 10,000, 100,000, or even 1,000,000. You want your number of runs after the burn-in period to be 100,000, 1,000,000, or even 10 million. For the purposes of this tutorial, we're going to set these numbers far lower. The file that we will be using, to run the structure analysis on, is called output.prn. As I told you previously, num-ins means number of individuals. There are 8 individuals, and there are 5,546 loci. I didn't tell you, but the ploidy of our data set is diploid, so we keep this number here as 2. The missing data value in our data set is -999. Our data contains labels for the individuals. We do not have data about putative populations. Our data contains a row of marker names, of labels for the loci. So we keep that as a 1, and we keep that as a 1. Next, we hit Control-S to save, or you can click this button here for save. Close main params. Next, open up the extra parameters file, extra params. We will keep most of the default settings in here, but we do need to make a few important changes. there is no population data or location information included in my data file. So we need to take this setting here for loci s pop, and we need to set it to 0. Next, hit save and close the extra params file. Now we are ready to run structure. Open up a fresh copy of terminal. We need to navigate to the folder that includes structure, as well as our sample data. Make sure that your data is included within the folder where you have the structure program. It's possible to have the data in a different folder, but it makes running it from the command line more difficult. So in our case, we're going to go to the bin folder from our home directory, and then we're going to go to that folder called console, which is where the structure program as well as our sample data is located. Here is how you run structure. That's the command. And then we're going to tell it how many K groups we want. So we want to run structure first for K equals 1 group, and we'll make the output file k1run.txt. Although we could call this output file anything that we like. I'm going to use a semicolon so that we can run multiple different structure runs one after the other. I'm going to put in the structure command again. This time I'm going to do it for K equals 1 again. This is because it is recommended that you have multiple replicates of your structure runs for each number of inferred ancestral groups. This one I will call K1 run 2.txt.
Next, I'm going to run structure for one inferred ancestral group again. So why am I telling structure to run the analysis for one inferred ancestral group? Why am I telling structure to run that 3 times? The reason is that every time structure runs, the results turn out a little bit differently. So what we need to do is run structure multiple times for the same number of inferred ancestral groups and average the results together from the 3 different times that structure ran, assuming that number of ancestral groups. In this case, 1 ancestral group. We will follow this same pattern, and I am going to write out more of this code for numbers of ancestral groups ranging from 2 all the way up to 10. In each instance, I will put in code for structure to run 3 times. So for 2 ancestral groups, I will have structure run 3 times. For 3 ancestral groups, I will also have structure run 3 times, and so on. And here's what your screen should look like. The dot and the slash here are on separate lines, not because I hit enter, but because in the terminal window, when it runs out of space, it carries over the text to the next line. So there's no space in between this slash here and this dot up here. It's just that it ran out of space, so it carried the text over to the next line. When you have everything typed out, press enter. When you run this on your real data, it will take far longer. It's running very fast because we set the number of reps and the burn-in period to be very small. I should say the number of iterations and the burn-in period. I will pause the recording and pick up again when it's finished running. That took about 2 or 3 minutes on my machine, so not very long. Another thing that we should do, if you have your cursor down here in the terminal window like I do, hit the up arrow key on your keyboard. This brings back the text. I don't want to run the analysis again, but what I do want to do is highlight all of the text and right-click if you're on a Windows machine or using a Windows-type mouse, or if you're on a Mac laptop, push down on the trackpad with 2 fingers and press copy. What we're going to do is save this text, so if we ever need to run this analysis or something similar again, we will already have the text written and we will be able to paste it into the terminal window and we won't have to type it from scratch. Open up Text Editor. If you're on my virtual machine, it is pinned to the favorites. Otherwise, you can search for it below. If you're on a Windows-type computer with a Windows mouse, you can right-click. If you're on a Mac laptop, push the trackpad with 2 fingers and press Paste. Now, press the Save button. Navigate to the Home folder, then find the Bin folder, then find the Console folder, which is where Structure is located. You may have Structure located in a different place on your machine, in which case navigate to that folder. And we're going to save this as I have the search window highlighted there. We want to come up here to where it says Name. We want to delete the name, and we'll put in Terminal Commands. And you can put today's date, or you can use the date that I'm using, which is the date when I made this tutorial, .txt. Then press Save. And now we can close Text Editor. So now we have this if we ever need it again. If you hit the down button, you can make all that text go away. We're actually done running Structure, so we can close the terminal window. Navigate to the folder where you have your Structure. And here are our results. This is for in assuming one ancestral group. And these are the results from that first run, assuming one ancestral group. These are the results from the Structure run, also assuming one ancestral group. This is the second time it ran, also for one ancestral group. This is for the run assuming 2 ancestral groups. The first time we ran it, second time, third time, and so on and so forth. This may be concerning because there are so many different sets of results. How are we supposed to make sense of them? For instance, if I were to take one of these results files and double click on it, there's all sorts of numbers and data in here, but what do we do with it? And how do we know which file has the right sets of results that we need? Or if we need all of the files, how do we summarize them together in some way so that we can see what we need? To answer those questions, you need to see the next tutorial, how to use pop helper in R to decide which results from Structure to use. See the show notes below for a link to that video. And once you've used that video to decide which of these files have the results that you should use, there is yet another tutorial for you to watch as well. That one is called How to Most Easily Visualize the Results from Structure and Make a Publication-Ready Figure. And once you have that publication-ready figure, if you haven't watched it already, I have a video entitled Brief Overview of the Program Structure for Population Genetics and What It Is Used For. That video will tell you how to look at the final product figure that you have made and interpret it. I have a link for that video in the show notes below as well. So there you have it, lots of resources available to you through my website for how to use the program structure.